the difference? I moved 2 in the left-hand side, so I doubled this distance, and I expanded this distance into 2 different distances. You see, dfxy fuv is here, and instead of the second distance, I took distance between the symmetric y to x and v to y, because the function is mixed monotone, so we can do it constructively. So this is the difference. K is also less than 1, and the progress we did is that in this condition, in this theorem, we do not ask continuity of the map of the function f. And let's take now the previous example. Our theorem applies to the example I showed you, and to which Bhaskar and Lakshmikantam theorem cannot be applied. And we use this. It is easy to see. We take absolute value and obtain this. We take the absolute value on the other expressions, and by summing up the 2 inequalities, we get exactly the inequality in our theorem, condition 13, with k equal 4/5, because we sum these coefficients and these coefficients, and so condition is fulfilled, and we have the existence of a coupled fixed point, because we can find x0 and y0 in this way, -3 + 3, to which fulfill this condition. So look, this is an improvement. This is an improvement for sure of this Bhaskar and Lakshmikantam. And what is important to mention with regard of this new theorem? No continuity is assumed, and we get the same conclusion. And also, it is important to tell you, I proved this theorem by using a totally different technique of that used in Bhaskar and Lakshmikantam, as the technique was very natural. I just give an idea. I don't know if I have in my slides mentioned this. Let's see. This is existence and uniqueness. I did not include the proof, the idea of the proof. And this application, so I show you how I did. So I just took, translated this problem to a fixed point problem. Let's put not x, because I write here I have u and v. Okay, I'll put x, u, v, and tx, tu, tv, and I converted this in such a, the notation is not very good, but I converted into a fixed point problem in this way. So I just applied the Banach fixed point theorem to this new operator in this way, and the conclusion followed. And these are also the improvement in the theory. This Bhaskar and Lakshmikantam asked for this condition, and this was this condition, and the two conditions are different, because having in view just a moment, yes, no, this is the reverse. I was wrong. This was the condition in Bhaskar and Lakshmikantam, and B is from Berinder. This is my condition, and of course, this is a less restrictive condition than the other one. So it also improved the applications of this theorem to two-point boundary value problems. I have here an example to show, it's good what I said. So this is invariant because this is 4 over 5 less than 1, and this is 6 over 5 is greater than 1, and this is the reason it does not apply. So there are many other developments. I just want to tell you another development in the remaining time. I showed this result to one of my PhD students, and I thought, look, this is a coupled fixed points. And he had a look on it. He said, why we should not consider these three sets and to define triple fixed points. Okay, I said, okay, but look, 2 factorial, so the permutation or 2 elements is just 2. So we had 2 elements, but permutation of 3 elements gives 6, and we need only 3. And the question is, which one from these 6 permutations, this combination should be taken into definition? And he said, I'll take this, this with red, and this he got to introduce this new concept, triple fixed points, in this way, and that is possible to have other combination. And we published together because he had a gap in a proof. I repaired it and we published together, and this was what is called hot paper. It is extremely cited. A lot of authors consider them triplet, quadruplet, multiple fixed points, and many other results were developed after this. And what was the problem? He proposed this definition for the triple fixed point. And when reading his draft, I realized it does not work. The proof in the case of coupled fixed points does not work, does not more work. So I discovered, and this is my contribution, I discovered that because of this Z, it doesn't work. So the final definition of a triple fixed point was this one. This is not, you cannot find in that list of 6. But it's the only way we can solve the problem. Why? Because here f is increasing in the first, decreasing in the second argument, and increasing in the again. So this was possible just changing this. And then here is the result. I mentioned for couplet, and for triplet, we also consider some examples. And we were disappointed that enough, because this is an example in our journal. I told you it's an example of a system of equation which is proposed to high school students, and it can be written as a triple fixed point theorem, but our theorem do not apply to this simple example. So our theorem is also not very large, and there are some other systems. So this leaves the possibility to define other concepts of triple fixed points using this kind of combination, and my student succeeded to, why was this not good, this definition? Because from 4 solutions, for 4 coupled fixed points, our theorem was able to catch only these 2 coupled fixed points, and not these ones. These ones were not obtained by using our, and so the problem was that we have this property, increasing with respect to x, decreasing with respect to y, and increasing with respect to z, and working in this way, only these solutions are found. And if we have this, then we could get the solution. And what my PhD student did, he considered again the first definition, and he applied this, increasing, increasing, increasing in all arguments, and he obtained also very nice results which were published. So here is my list of conclusions. I read only a few of them. We should be aware of the fact that our theoretical results cannot be applied to very large classes of applications. As I've seen here, I've shown you here, some simple applications are not covered by our theoretical results. This means there it is room for improvement. So we should try to find other assumptions, weaker assumptions to find other theoretical results to solve this applicative problem. So we need more papers in fixed point theory with applicative part, and we should enlarge the area of applications. I did this in my previous presentation when I presented you the class of functional equations. So now if we go to see what classes of mappings, of problems are solved by using fixed point tools, we'll see mainly differential, integral, integral differential, and now fractional differential, fractional integral, and no many other applications. We should enlarge this class, and once again I am happy to know that Professor Murthy is dealing with some applications to data science. I do believe in this. I know about some researchers working in this area. They are trying to apply in machine learning and in many other areas. I am confident in this. The Thailand researchers did a very nice work for applications in image recovery. In image recovery, Professor Swantai and his team, they did very nice, even in machine learning. They are working for a few years. So as a final conclusion for today, we should obtain as many as possible constructive fixed point theorems. This means a theorem that we can apply to solve a problem concretely, so constructively. It provides us a method to construct the solution. So I'm in time exactly, sir.
Thank you, Professor Asil Barinde, and very nice presentation. And I think this coupled, tripled, and even n-tupled for odd and even, because I reviewed so many papers during 2010, 11 to till 18. Yeah, sometimes your paper also.
Ah, really?
Your paper also. Is now open. So my student worked. She worked. Yeah, we have sent a mail also during that time.
That time you have replied me.
Really, I replied?
Yes. Yes.
Okay, thank you. I didn't remember. All right, I'm old enough to not remember.
So you are very wise even in your absence.
Okay.
So she
Okay.
worked on coupled and tripled
I
and,
see.
and tupled also.
Uh-huh.
Some paper published in this American journals. Yeah. Yeah, and tupled also. Professor Imdad, he published initially for I think odd, right? When n is odd. He published some paper on when in case of even he published for n is equals to odd, not for n tuple. Yeah. He published that one. So Professor Imdad also worked.
I know, I met him. I met him in Pakistan.
You met him?
I met him.
No, he
In
didn't
that,
go to-
he's not from Pakistan?
No. He is
Ah.
from AMU.
But it's a
Javed
similar
is
name
so-
in...
His name Pakistan Liaquat Ali Khan.
No, it's a similar name. I'm confusing, so these names.
Maybe.
In that, where is him?
He is from AMU. He is supervisor of Javed Ali.
Uh-huh.
Yeah.
In Aligarh?
Yeah.
Ah, no, I am confusing the person, but there is someone with I starting the name in Pakistan, in Lahore.
Javed, his name, one is,
He's also, I thought it's about him.
he's postdoc student.
I know.
of, Willie Roads.
I met also him. I met.
Mujahid Abbas.
I see.
He's Mujahid Abbas. He is from Pakistan.
Okay.
And we had some collaboration, and I know him very well. Yeah. So very good presentation, and I think professor has given nice things. And actually, those three people, particularly Bhaskar and Lakshmikantam, that paper in nonlinear analysis, I think the paper published in that. And they have given the idea of the coupled fixed point and along with the application in boundary value problem. That was the paper, right? Bhaskar and Lakshmikantam, the two papers are there, Tenali Bhaskar and V. Lakshmikantam. And after that, I think you have taken up and we have also taken up. So it was like that. Any question from the audience? If no,
Okay.
we have the tea time right now, and there is one actually small change, as I said. So the change is in place of the open discussion in the first half. Now it is after the tea, open discussion will be there. Okay, after the tea. So we three are here, and at 4:15 we start this open discussion. And for the books, you people said it is in my car. So you can go through those books. I will ask Uma Devi Patel madam to get the books from my car with the help of some students. So all the books are there. So you can see those books, and whichever book you like for the photocopy or something, you can take. There is one Taj copier is there opposite to road, or you can ask our this MSc students for Xerox copy. Okay, and most probably I shall try. Actually, every day I try, but it is a late evening, 12:30. So I miss many things. That's why I could not post the presentations of Professor Brande. So, but today I shall try to positively do it. Okay. One more thing is you are actually attending for the past 4 days. Tomorrow is the last day. And you have to fill the feedback forms. So you will be given each one of you is given 5 feedback forms for the 5 presenters. Okay, you have the names also, I think, and you are sent all the schedule every day. Please go through this is a GAN group, and please submit your presentation, feedback forms to Madam Dr. Uma Devi Patel positively by tomorrow morning, because these are very useful, and we have to submit the feedbacks to the GAN National Coordinator, Hyderabad. Okay. So our link is available at the Hyderabad main portal, apart from our own. So anyone can see that, open that link, and can see the YouTube what I say is streaming. YouTube streaming live is going on, but after that you will find the recording forever. So along with this, you can find the YouTube streaming of 2007 October. I think it is also the same 23rd October started, and I think it is around some 28th October finished. Professor Dorel Mihach, this is. Okay, that is he is Suthep Sunthai. He is the student of Dompong. Yeah. So earlier only Dompong is the only professor in Thailand. He is the second professor in Chiang Mai University. Chiang Mai is in mathematics. In mathematics. In yes. After that there are many several private colleges. Now, like anything. Now these days everyone is a professor, and in India, you know, we have many professors in India. No, no, of course it should be. It should be. No, no, I'm not talking about the Thailand. In many part of the, yeah, not easy. Yes, yes. No, I know that there are many in European countries. It is not easy. There are many. They retire simply even senior lecturer or associate professor. Even they don't go for the professorship also. Yes, 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 yes. Professor for the Professor Zung, I have written the recommendations for his full professorship. We can go for tea break after 15 minutes, 10 minutes, I think.